Hello, this is SSNL Venkateswar Rao, Faculty of Electronics and Communication Engineering. The subject is random variables and processes. In this video, we are going to discuss about the basics of random variable. Why we require to study about random variables and processes? To understand certain engineering subjects, we need the knowledge of random variables and processes. Especially in communication systems, the knowledge of random variables and processes is very much essential. As we already know that noise and information sources play an important role in communication systems. And we also know that noise and information sources are random in nature. To have a good model for noise and information sources, the knowledge of random variables and process is very much essential. Now we discuss certain terms involved with random variables. The first one is random experiment. What is random experiment? An experiment whose outcomes are random is known as random experiment. To explain this, I'll take two examples. One is flipping a coin. If you flip a coin, there are two possibilities. Either you are getting a head or a tail. It means there are two outcomes. If you repeat the experiment, each time we are getting two outcomes which are random. The another example is throwing a dice. We know that dice has got six faces. If you throw a dice, then there are six possibilities. That is getting 1, 2, 3, 4, 5 or 6 on the front face of dice. It means there are six outcomes. Each time you are repeating this experiment, you are getting six outcomes which are random. The term that we discuss here is sample space. What is sample space? Sample space is the collection of outcomes of a random experiment. We have just seen that in a random experiment we have outcomes which are random. In this diagram, all these dots are the outcomes of the experiment. Each dot is an outcome. So all these dots are outcomes of the experiment which are indicated as a small omega. The collection of all these outcomes is known as sample space, which is indicated with capital omega. Or we discussed about random experiment and sample space. Now we try to understand what is a random variable. We consider a class of students. So sample space in this case is a class of students. Each dot in this sample space indicates a student. Now we pick up a student randomly here and his weight is found to be 50 kgs, which is marked on this real line. Similarly, I picked up one more student here whose weight is found to be 60 kgs, which is marked on this real line. Now we define what is a random variable. Random variable is a function which maps the student with his weight. It means it is mapping the outcome with a real number. In this particular case, it is mapping the student with his weight. So if you denote random variable with WS, the capital W indicates the weight of the student and S indicates the name of the student. So the randomness here lies in the way we pick up a student. But the value of the outcome is a real number that we have to understand here. So randomness lies in the way we pick up an outcome. In this case, we pick up a student. So we define the random variable as a function that maps the sample space with a set of real numbers. Suppose if I take a sample space like this with so many outcomes, as in the previous case, if these are students, then if you measure their weight on a real line and mark them, it gives us a real number. So the random variable is a function that maps the sample space with a set of real numbers. And we have seen that it is indicated as XS. or WS or whatever letter we may use. Normally a capital letter is used with the parenthesis, the outcome is marked. In normal conditions, we may ignore the parenthesis and we may simply write capital X. So random variables are generally indicated with capital letters. We need not to mention the outcome in the parenthesis. Random variables are broadly classified as two types. They are discrete random variable and continuous random variable. We'll take them one by one. We consider discrete random variable. We know what is discrete. Discrete means finite number of values. If the random variable takes on only finite number of values, then that random variable is known as discrete random variable. Here we consider two examples. The first one is flipping a coin. If you flip a coin, as we already seen, there are two outcomes, getting a head or a tail. If you indicate head with 1 and tail with 0, there are only two values. The random variable either can take a value of 1 or 0. So they are discrete in nature. Similarly, the second example is throwing of a die. If you throw a die, there are 6 outcomes. The sample space consists of 6 outcomes. There are 1, 2, 3, 4, 5 and 6. These are the 6 outcomes we have. So random variable can take any one value out of this. So there are only 6 discrete values. So these two are the good examples for discrete random variable. The continuous random variable. As the name emphasizes, that is continuous. The range of values here is continuous. That is, it has got infinite number of values. So random variable that takes on any value in an observation interval is known as continuous random variable. So here the range of values is infinite. One good example for this is a noise voltage amplitude. Suppose you consider a noise voltage something like this, and if you measure the noise voltage at any instant, it has got certain value. Again at the another instant it has got another value. So the range of values are infinite. It can take on any value, whereas in discrete it can take only fixed values. So this is the difference between continuous and discrete random variable. So in this video, we considered some basics of random variables. We discussed what is random experiment and sample space. We defined random variable and what are the different types of random variables.